let's start by doing I think the last Sunday I gave for two, the fall 2010. Well, no, it's an older one. Right? Which part do you want us to do first? 1, 2, or 3? 1. Yeah. That was a loud one, so nobody talks. So we're going to start with 1. Okay. So the first one is talking about, let's see, correct statement. So you make sure every time, try to put in bold so you will not take it wrong. So let's start reading. Zero order reaction means the reaction is equal to 0. Okay, zero order reaction has nothing to do with activation energy. It has to do with what? How the rate depends on concentration, right? So you really don't know how to get this paper with me. Should I write down things? Probably. Did you read all of that? So zero order, the order refers to how the rate depends on concentrations, not about activation energy. So that cannot be. The degraded rate law expresses how the reactant concentration depends on time. That's correct, right? Remember we have two kinds, the integrated rate law and the differential rate law. The differential rate law is before integration. So you have rate as a function of concentration. When you have the integrated rate law, you take the differential, you integrate, and you get now concentration as a function of time, right? So the answer is B then. If you want to confirm, you can read the rest and you will see that they're wrong, right? Any question here about this problem? So the answer should be B, right? Answer is B. Okay, let's go for the other one. What is the incorrect statement? So in this case, it's incorrect. The elementary steps of a reaction would sum up to give the overall reaction. That's correct. That's one of the requirements to have a correct mechanism, right? Remember, we said yesterday. A proposed mechanism must always be consistent with experimentally observed rate law for the overall reaction. Absolutely. That's one of the two main requirements, right? And then intermediates can never be isolated. We said that intermediates sometimes they can be isolated. And a chemical species that is can never be isolated. That's incorrect. And so the answer should be C, right? A chemical species that is formed and set up during a chemical reaction is called intermediate. That's the definition of intermediate. And a single reaction step has one only transition state. We didn't talk about it yet, a little bit yesterday, but you pretty much know from the example with two cars, right? You get that total kinetic energy from both of them at the moment of contact, right? And two molecules are together, or three molecules together. All that energy is together now there. It's become kinetic energy, has become potential energy. That's something that is really ignored many times in the books, and it's good to understand it. When the molecules are coming with high speeds, kinetic energy, right? The complex of these are molecules now. That's why it's called activated complex. That complex, that group of the two molecules now, or three, randomly free, has high energy. What kind of energy has high energy? Potential energy, because that kinetic energy now, together with a complex of the two molecules, let's say with two molecules, now it's become potential energy. And basically what happens is the bonds, some of the bonds become elongated, takes energy to do that, and they start breaking. And that's the energy state that we call transition state, or activated complex. That has a high energy. The kinetic energy became potential energy. Now that the molecule has higher energy, some bonds are longer. That means they're ready to break. The activated complex, right? Okay, let's go to the next one. The next one, it needs a little bit of work. So in order to answer it, it seems like they have to do some work, a little bit of work, right? Where should I concentrate? Did you read all the questions? As you can see, as you read from top to bottom according to our lectures, right? They're all correct, right? So it must be this one, but if you have a doubt in one of these four, then you don't really know, right? So in order to confirm it, if you have a doubt about this four that it might be incorrect, then you really have to work this out, right? So how are you going to work that out? The units of the rate constant of an overall fourth reaction order is n minus 2 to second minus 2. So everybody can see here if I write. It's going to be a problem to Berlin to do it probably. Can someone give me a couple of pieces of paper? Sorry, I forgot to do it. Because I don't want to write here because I think it will be confusing when I will cover the problem. Just two pages. One and another one. That's enough. This is more than enough. Okay, so let's work it out, right? The units of the rate constant. So we have a rate, fourth order, so the rate, right? The rate constant, and fourth order. That means if there is a reactant, let's say A, it's going to be in the fourth. It doesn't have to be just A. It could be A, B, C, B, or it could be A squared, B, C, or it could be A cubed, B, right? It doesn't matter. The overall order is 4. That's what it matters, right? And so from this now, we know that the rate is molarity per second. So it will be K times molarity to the fourth. And so from here, you will have, this one will become 3. And so K is going to be n minus 3.
Professor, would you move up, please?
So from here you will have n3 goes here, it becomes n minus 3. Second minus 1. Right? You just solve it. Is that clear? Okay. So by that way you confirm that that's the incorrect one. Just in case you had a doubt that one of the other 4 was incorrect, right? That's why you confirm this is the incorrect one, right? Okay, let's see the other one. Choose the correct statement. Correct statement, right? The exponents in the rated law of multiple steps depend on the geometry of the reaction. Incorrect, right? The exponents of the rated law of an elementary are experimentals. That's the opposite of, right? Of what we know. The higher the value of an exponent, that's again the opposite of what is there. The higher the exponent is, the more sensitive is the rate of the reaction to the concentration of the change, right? Remember? Reaction rate does not depend on temperature, but reaction rate does depend on temperature, but not the rate constant. Doesn't make any sense. Rate constant is really a rate. Remember we said rate constant is nothing else but a rate. The rate of the reaction when the constraints are 1. So, it's a rate of a reaction, it has to depend on temperature, right? So, both. So, the answer should be 4E, right? For 3, because we use why it's not B. The exponents of the rate law of an elementary reaction are determined experimentally. We said that when we have an elementary reaction on step, right, the orders on each reactant are determined by just looking at the chemical equation. We don't need to do experiments, right? Come in. We had a good time. Okay, so should we go to the next? Yes? Okay, this is the next one. A four-step reaction involves an X transition state and white intermediates. If you really remember an energy level diagram, you can never forget this. So here is the energy, and the energy level diagram is like this. Always you have mountains, right? You start with reactants here, somewhere there you have the products. Each of these mountains is one step, because each step has an activation energy. So 1 step, 2 steps, 3 steps. If you have 3 steps, then you always have 3 transition states, the higher energy of the peaks. So the number of steps is always equal to the number of transition states, to the number of activation energies, but the number of intermediate is always x minus 1, if x is the number of steps, because you see intermediate here is this one, right? Intermediate here is this one, right? The low energy. The reactant and the product is there. If you have 3 steps, you have 2 intermediates. So you can imagine now, if you have x, it will always be x minus 1 intermediates. Can you see that? Right? Everybody saw it? If I make only 2, then I have 2 steps, 2 transition states, and 1 intermediate. 2 minus 1, 1. Right? So the answer should be? The answer should be D. Okay.